So now the fun part comes when we have to reverse this whole process. So we know how to find a probability from the table if we have a z-score, but now we have to work in reverse. So if I give you an area or if I give you a probability, you need to backtrack and tell me what the z-score was. So it seems like it's going to be difficult, but it really isn't. It's going to be pretty fast. So we're basically working in reverse. We're working backwards. So we still want to draw our picture and identify the region under the curve that represents the given probability. If that region is not a cumulative region from the left, work instead with a known region that is a cumulative region from the left. So remember, we always like the left side to be shaded because that applies directly to the table. So if it's not in that format, we want to somehow change it so that it is. So we're going to see how that works. And then once we have it as an area to the left, we can then use the table and find the closest probability in the body of table A2 and identify the corresponding z-score. So let's see how that works. So we still have a normal distribution with mean 0 and standard deviation 1. So they want us to find the indicated z-score. So this one is giving us 0.9798. It's on the left side of the z-score, so that's a plus. So that means we should be able to go right to our table and look for this 0.9798. Excuse me. So now the first question is, or I should say the next question is which table are we going to look at? We got two tables. We got the positives and we got the negatives. So which one should we use? Well, look at where our z-score is. Our z-score is on the right side of the middle. If it's on the right side of the middle, we better be using our positive z-scores. So now we got to try to find that 9798. And so we're just looking around in here, and if we look, it's right here. I know it's a little small. Zoom in. So 97, where is it? Where did it go? There it is, 9798. So now we have to go in reverse and say, okay, well, where does this lead us to on the outside of our table? So 9798 puts us under the 5. And if we go across, 2.0. So 0.9798, if we go up, it's 0.05. And if we go to the right, it's 2.0. So now what do we do with that? Well, remember, you got to kind of like smush it back together. If you smush it back together, that gives you your z-score. So we should end up with z equals 2.05. Another way to think of it is if you just add those two numbers together. If you add them together, make sure you're careful with the decimal points, you will get 2.05. So what about the next one? The next one, we got 0.1075, and it's talking about this little region here on the right. Well, so should we look this up in our table? Hopefully you're saying no, because this is an area to the right, and our table doesn't tackle areas to the right. We need to know what's on the left side. But how do we do that? Well, remember, the whole thing is equal to 1. So if we subtract from 1, that should give us our decimal. So 0.8925. So 8925 is really what we want to look up on our table. And again, do we want to look at the left hand or the negative side or the positive side? And it's on the right, so we better use the positive again. So 8925, where is 8925? Right there. So if we go across, we get 1.2. We go up, we get 0.04. So 0.8925. So we got 0.04. When we go up and over, we get 1.2. So z better be 1.24. Done. All right, let's try a different style problem. So if we look at this one, we got to assume that a thermometer reading is out. We're back to the thermometers. They're normally distributed, mean of 0, standard deviation of 1. Thermometers randomly selected and tested. In each case, draw a sketch, find the temperature, blah, blah, blah. All right, so now the wording's a little different. It says find the 95th percentile, P95. This temperature is the temperature reading separating the bottom 95% from the top 5%. Now, the problem with this one is that it seems like it's much more involved than it really is, because they're saying, okay, we got 5%, we got 95%, we got to somehow put those values into our diagram, and that's completely wrong. And the reason why is because all they're doing is saying what single temperature causes a 5%, 95% split. And make sure you have which side is on the left and which one's on the right. The bottom 95% means the left should be 95% and the top should be the right 5%. So basically, we're going to have to be on the right-hand side. They want to know what Z is so that this is 5% and that this is 95%. Now, okay, so that's what our picture looks like, and we know what we have to find, but where do we go next? Well, we got two percentages we could choose from. Which one should we use? Well, hopefully you're saying this one, because it's on the left. We don't care that this is 5%. All we care about is what's on the left. So now, if we have a probability equal to 95%, we know that that's equal to 0.9500. So now we have our starting point. So we should be able to get a z-score from this. So let's take a look at our table. We better be looking at the positives again. So we want 0.9500. Well, we got 0.9495, and we got 0.9505. Well, neither one of those is exactly what we want, but look at this star. It looks like a little dirty there. There's a star there. If we follow the star, it says right down here, 0.9500. That gives us a z-score of 1.645. Now, it is a special z-score. It has 3 decimal places. Most of them do not. Most only have 2. So there's a couple of them. This is one of them. So 1.645, and now we should put the units because it is a temperature. So 1.645 degrees Celsius is our z-score. Now this next one, if 2.5% of the thermometer readings are rejected because they have readings that are too high, and another 2.5% are rejected because they have readings that are too low, find the 2 readings that are cut off separating the rejected thermometers from the others. All right, so let's get our picture. So we want 2.5% that are too high. So I'm thinking we have this little piece over here is 2.5%. Likewise, on the other side, we got this piece is 2.5%. And we got another z-score here. Now, some people like to put a little subscript to make them unique. So if I said this was Z1 and this was Z2, but you don't have to do that. It's not a big deal. So, which one do you want to work with? Well, look at what's being shaded. We got this piece is being shaded, and we got this piece is being shaded. Hopefully you're looking at this one because it's shaded to the left. So let's start with that one first. So if we got our probability, and I'm going to cut to the chase and change it to a decimal. Now, I'm always going to be using 4 decimal places when I'm writing probabilities because that's what our table deals with, 4 decimals. So we want to look up that probability first and see what we get. Now, which table? Positives or negatives? Hopefully you said negative. So 0.025, where is it? 250. It's exactly there. So that looks like negative 1.96. So this is going to give us z equals negative 1.96. Now, here's a question for you. Because this is a nice symmetrical graph around 0, what is your guess at what this z-score is going to have to be? if it's nice and symmetrical, you got negatives on this side, you got positives on this side, hopefully you're guessing that it's going to be just the positive. And that's exactly right. Z will be equal to positive 1.96. Now, why? Well, let's prove it. We know that this little chunk is 2.5%, so now the question is what's this whole other side of this graph? If this little chunk is 2.5%, then this whole chunk, don't worry about this little piece, the whole thing would have to be 97.5% because you want it to add up to 100%. So if I looked at a probability of 0.9750, let's see what happens. 9750. 9750 is right here. 1.96. So you still get the same result. So that's kind of how this is going to work. You know, so you got to be careful. Sometimes those probabilities will be a number right on your table. Other times they won't. So like that star case, we're going to see some more problems like that where it doesn't fall exactly as one of those probabilities. And we'll see what to do in the following videos. Alrighty, stay tuned.